Hello everyone, I'm Maria from IPACK Solutions, Cadence's channel partner in the MENA region. Welcome to our second video in the Celsius Studio series. In the previous video, we demonstrated how to perform an electro-thermal co-simulation in Celsius layout. In this video, we'll showcase how to perform a static electro-thermal co-simulation in Celsius 3D Workbench, which is the tool used for creating and analyzing 3D and MCAD models. So here I have my Celsius 3D Workbench tool open in front of me. I'm gonna create a new design quickly. Over here I have my Canva, I have my toolbar and my project window. In my project window, I have all of the steps that I need to set up before starting my simulation. This is whether for my static analysis or for my transient analysis. Now I'm gonna start by importing my design. So I'm gonna go to my modeler window, import parts and then model. I'm gonna quickly search for my design, which is over here, and I'm gonna import it. But first, over here you can see all of the different file format that I can import inside of 3D Workbench. Now the design that I will be using in this demo is a BGA design with two wire bond dies that are next to each other. The first thing that I want to do is I want to start by modeling a few things for my components. I want to add my solder balls, I want to add a molding for my BGA, I also want to add my two dies as well as a demo PCB, because basically your BGA will always be on a PCB. So I want to see how the temperature is being transferred from my BGA to my PCB. So to do this, I'm going to go to draw parts and then components. I'm going to start by adding the parameter for my solder balls. So over here I need to enable on which BGA I want to add my solder balls, and over here I specify the parameters for these solder balls. Alright, I also can specify the material, so it will be a solder 63 material, the filling will be an FR4 material, and then I can select OK. So over here now you can see my solder balls. I'm gonna reopen this window again because I need to create the model for my dies and my mold, or basically the encasing of my BGA. So let's add two dies, let's map them to the components on my circuit. Alright, so let's specify the thickness as 0.1 for both of them. The material I want it to be silicon. Dies usually are silicon. I want to add a die attach. And finally, I want to specify that the die attach material as molding compound. Now for my mold, let's add a mold. This is for my BGA. I want to specify a length of 9.6 for both of them, and the thickness 0.5, and same, it's going to be a molding compound material. Now for my board, I'm gonna enable it. I'm gonna keep the length and the width as it is. However, for my material, I want to specify as copper, and as the dielectric material, I want it to be FR4. And this is to make sure that we are modeling correctly our PCB to get a more accurate result of how the temperature is being transferred from my BGA to my PCB. Then I'm gonna click apply and OK. So here now you can see my PCB, my BGA is here. Here is I have my mold or the encasing for my BGA. We already saw the solder balls, and if I zoom in, you can see my two dies. Now I'm gonna go to my home and specify the options for my simulation. So it's a thermal analysis, an electric analysis, as well as let's specify the ambient temperature as 22 degrees Celsius. Then I'm gonna select OK. Now, these are the different parts of the simulations that I need to set up. First, at the power input, so which components are basically generating the most power, which are my two dies. So let's go to my parts section. Let's select D1, right click anywhere, and select it as a heat source and specify its power as 0.5 watt. Same for D2, my second die, right click, heat source, and it will be generating 0.2 watt. Right, now I need to specify the heat transfer condition, and this is for my board to see how the temperature is being transferred from my package to my board. I'm only gonna enable these two options. So let's select show only. I'm gonna select faces, so I'll be able to only select faces, not the whole object. Select top, select this, right click, and then thermal boundary condition and heat transfer coefficient. Let's change the heat transfer coefficient to 15 for the top part of my board. And I'm gonna do the same for the bottom part of my board. So let's select it, right click, thermal boundary, heat transfer coefficient, and let's put it as 15. Right, now let's show everything. And here I have my design. I'm gonna first also start by adding now my VRM. And basically the pins for my VRM will be the pins for my BGA. So let's select all of the pins for my BGA over here. Let's right click and show only these pins. Let's show a top view, and let's right click, 3D patch, and create VRM. Let's select all of my pins that I will choose for my VRM. I'm gonna select a nominal voltage of 5 volts. The pink pins will be negative pins, and the blue pins will be positive pins. Okay, now that this is done, I can select OK. And the next thing I need to do is I need to set up my sinks. Basically, are my two dies over here. So I'm gonna first group by and then select geometry layer and select these two layers, which are the pins for my die. Right click and select show only. Now let's start by specifying the pins for my sinks for my first die and then for my second die. I'm gonna right click, 3D patch, and then create sink. Let's select the pins over here for my first die, this one and this one as well. It will have a 2 ampere current, and let's specify the blue pins as positive pins and the pink pins as negative pins. Same for this one, and then OK. Now let's do the same for my second die. I'm gonna right click, 3D patch, create sink. This will have a current of 3 amps, and I'm gonna select my pins over here. Alright, this one will be a negative pin, this one also will be a negative pin, and I believe this one will be a negative pin. Alright, so let's select show all. Now that I have done all of my setup, I can start my simulation. Since it will take a few minutes, it will take around 15 minutes maybe, I'm gonna open a previously solved results. So here I have my results, they are loading. Alright, so you can save your results if you wanted to load them again. So for example, I can first specify if I want to see the potential, temperature, the IR drop, the current density, if you wanted to, the power loss. If you want to see the IR drop, maybe you want to see the surface. You can see the most voltage drop is on the pins of some of my dies. But our focus now will be the temperature. For example, if you want to see the temperature, you can also see the mesh that was created. For example, you can select on which structure you want to see. So here you can see the mesh that was done for my wire bonds, for my dies as well. But you can also just check the surface temperature, so you can see which component is have a more increase in temperature. You can also see the temperature for the individual wire bond dies as well. And with this, I'm gonna conclude this video where I have introduced how you can do an electro-thermal co-simulation inside of the Celsius 3D Workbench. In the next video, I will be using the same design to do a transient electro-thermal co-simulation. Thank you for your time, and I'll see you in the next video.